as the question says, an elevator is descending with uniform acceleration. To measure the acceleration, a person in the elevator drops a coin at the moment the elevator starts. The coin is 6 feet above the floor of the elevator at the time it is dropped. The person observes that the coin strikes the floor in 1 second. Calculate from these data the acceleration of the elevator. Let us first draw a rough sketch for this problem, in which we are having an an elevator which is descending with an acceleration, let us suppose A, and we have dropped a coin from here at t equals to 0. Now we know this will free fall with an acceleration of g, and this distance has been given as 6 feet, this distance. Now let us solve this problem with the relative concept. If we consider the coin with respect to this elevator, then the relative acceleration of the coin will be g minus a downwards. Also, we have the relative displacement or the distance as 6 feet, and we need to find out the acceleration of the elevator, that is a, where we have been given the time equals to 1 second, and the relative initial velocity is obviously 0 because both were at rest. So we can apply the second equation of motion, in which s equals to ut plus half at square. Putting the values over here, we get 6 equals to 0 plus half the acceleration g minus a into 1, giving us acceleration equals to 20.34 feet per second square. Now, in all such questions in which you employ the equation of motion for the relative concept, take care that all the units, that is all the variables present in this equation, should have the relative quantities only. That is, the displacement should also be relative, the initial velocity should also be relative, and the acceleration should also be relative.